Is my screen in any way freezing up, or the vocal?
Nope, very good.
Okay, swell. I wanted to do one more proof from last time. And so let's prove this last identity. Let's prove that cotangent over cosecant minus cosecant over cotangent is equal to negative tangent x sine x. So we've got cotangent x over cosecant x minus cosecant x over cotangent x, and then negative tangent x sine x. See. Okay. Ben, I made you co-host.
Okay.
So let's see. What can we do? I mean, there are several different things we can do, but what is one thing we can do if we've got cotangent over cosecant, cosecant over cotangent? They're both written as fractions, and we've got a negative in the middle.
We
Try
can
and write them.
use.
Say it,
Sorry,
Mark.
go ahead.
No, you go ahead.
Okay. I was just saying like splitting them. I don't know if that's all right. Like, oh no, I think it will be like the same outcome, or maybe just say like trigonometric identities. I'm not so sure, to be honest.
Okay. What were you gonna say, Andrew?
I was gonna say split them into cos and sin.
Okay, so make everything in terms of cosines and sines.
Yes.
And let's just put in the side here, cotangent x in terms of sines and cosines is
It is the reciprocal of tan, which is sin over cos.
so it'll be cosine over sine. Good. And since we're over here, what is cosecant x in terms of sines and cosines?
One over sine.
Good. So do you think it would behoove us to replace the cotangents with cosine over sine and the cosecants with 1 over sine?
I do.
Okay, let's do it. So we've got cosine x over sine x over 1 over sine x. And then we have 1 over sine x over cosine x over sine x. And what do you notice about the two complex fractions? What are the little denominators or the inside denominators?
They're all sine.
They're all signs. So what can we multiply numerator and denominator of both fractions by?
Sine.
Good. So with the first fraction on the left, the signs in the numerator divide out. What are we going to be left with in the numerator of the first fraction? If we multiply cosine over sine by sine, what divides
Cosine.
out? What? Yeah, good. And in the denominator,
1.
good. That's cool. And in the numerator of the second fraction, the signs divide out. What's left?
One over cosine.
Yeah, if we do the whole thing over, yes. So in the numerator, 1 is left. In the denominator, cosine is left. So this is actually quite a big improvement. We started with 2 trig functions, and now we have only 1. What could we do at this stage to move forward? Because we know we want to end up with tangent, which is sine over cosine, and a sine. And we only have cosines.
You lost me here. I have no idea.
So we've got 2 fractions. How can we combine them?
By finding a common denominator.
Very good. What could we multiply 1 by to get cosine x?
Cosine x.
Yeah.
Good. Okay, so now this first fraction is going to become cosine squared x divided by cosine x. And the second fraction is going to stay 1 over cosine x. Can we combine those fractions now?
Yes.
Good. So we've got a common denominator. And in the numerator, cosine squared x minus 1. And this is actually looking really good because we've got a cosine in the denominator and tangent has a cosine in the denominator, but we've got some signs that are missing. How can we get to those? If we have a cosine squared x, excuse me, minus 1. What's the most important Pythagorean identity?
Cosine squared x equals sine minus 1.
Okay, and we're going to think of it the other way, but yes. So let's just write it. Cosine squared x plus sine squared x is 1. We've got cosine squared x minus 1, so let's subtract 1. And that means we need to subtract a sine squared as well. So we get cosine squared x minus 1 on the left, negative sine squared x on the right. So we can replace cosine squared x minus 1 with negative sine squared x of cosine x. And why are we done? If our goal was to get to negative tangent x times sine x, why are we done?
Because you make well, you separate the sine square x and then you just like do the tangent formula and then just times sine x.
Very good. So the one of the sines divided by cosine is tangent. And then we have an extra sign. And that's exactly, and this negative out to the side, and that's exactly what we wanted to get. I'm going to stop and restart the recording so that this is like a coda to the earlier material. Any questions?